Hello. In this video I will briefly recall all the rules, the computational rules with real numbers. And one reason for this is that, well, you are going to perform computations on real numbers, so it's good to repeat how you do this. And the second reason is that when we will define arithmetical operations on matrices, like matrix addition or matrix multiplication, we will try to check if the same rules apply for those computations. So this is the second reason why it is good to repeat all those rules. So let's start. Rules for computations with real numbers. And you know that you have basically two kind of arithmetical operations with real numbers. You have addition and multiplication. Well, you could also say that you have subtraction and division, but actually subtraction is just an addition of an opposite number, and division is multiplication by an inverse. So basically you have just two operations, multiplication and addition. And for both addition and multiplication, you have the so-called commutative law. And this law tells you that addition and multiplication are not dependent on the order of the terms or factors. So these numbers here in case of addition are called terms, and when you multiply numbers, then you call them factors. So if you take like 1 plus 2 or 2 plus 1, you arrive at the same result. And the same thing with multiplication. 3 times 7 is the same as 7 times 3. It should be obvious. Then the associative law tells you that you can, well, put parentheses as you like. And what does it mean in practice? This means that if you have to add three numbers to each other, it doesn't matter if you first add the two second numbers and then the result is added to the first one, or if you add like two first numbers and add the result to the third one. You will arrive at the same result. And the same for multiplication. Then you have the so-called distributive law, which kind of connects multiplication with addition. And sometimes this rule is called a parenthesis multiplication. So it tells you basically that if you have some factor and it has to be multiplied by a sum, then you have to multiply this factor with each and every element in the parenthesis, so each term of this sum. And if you have hard time remembering this rule, then you can use the following mental picture. Well, it works, of course, only for A, B, and C, which are positive numbers. Then you can think of them, of A, B, and C, as of length of some interval. So this interval has length A, this one has length B, and this one has length C. So from here to here. And well, what is the left-hand side of this equality? It is the area of the rectangle with one side of length A and the second side of length B plus C. So you know that the area is length times width. So it is A times B plus C. But you can split this rectangle in two rectangles. One of them has size A by B and the second one A by C. So the area of this first one is A times B and the area of the second one is A times C. So the total sum of the areas of these two rectangles are AB plus AC. But the sum of the two areas is exactly the same as the area of the total large rectangle. So this means that indeed A times B plus C is equal to AB plus AC. But this is just a geometrical interpretation. It's not a proof of this rule, because actually this rule is just a rule which does not need any proof. Rules like this are called axioms. These are just truths which are in some way reasonable and which we follow in our computations, but they don't need any justification. But it is good to have this mental picture if you don't remember this rule. The next one, the neutral element of the addition is 0, and this means that if you add 0 to anything, you will not change this anything. It will just be like the same thing. So addition of 0 changes nothing, and in this way 0 is the neutral element of the addition. And the same way for multiplication with 1. 1 is the neutral element of multiplication. It means that if you multiply anything by 1, you will not change this anything. It will still be the same number. The next one, the zero product property. The zero product property tells us that if a product of two numbers is equal to 0, then it must, the sum of these numbers, maybe two of them, but at least one of these numbers must be equal to 0. So only the product of two or more numbers is equal to 0, only if some of the factors, some of the numbers is equal to 0. This small sign, it is OR. It's a mathematical symbol for OR. And this is implication. It means that from this follows this. So if AB is equal to 0, then either A is equal to 0 or B is equal to 0, possibly both of them. But at least one must be equal to 0. Then we have this cancellation property. And what does it tell us? That if AB is equal to AC, and this small guy is a mathematical symbol for and A is non-zero, is different from 0, then B must be equal to C. And why is it called a cancellation property? Well, you can think of it that you can divide both sides of this equality by A, and the equality will be still preserved. And this is why you have to demand that A is non-zero, because, well, you cannot divide by 0. It's one reason. And the second reason is that if A is equal to 0, then this equality is always true regardless of B and C. So if A is equal to 0, you cannot have this conclusion that B must be equal to C, because, well, 0 times 7 is equal to 0 times 34, but 7 is not equal to 34, right? And you use this cancellation property, for example, in cases like this. When you know that 2x is equal to 2y, then you can be sure that x is equal to y. So you have made this cancellation by 2. So in this case, a is equal to 2. It's obviously non-zero. B is equal to x and c is equal to y, right? So in this, you apply this cancellation property in this way. And the last property, existence of inverse element. So each element A has its, well, kind of inverse element, but inverse in this case, in the case of addition, we usually don't use the word inverse. We would rather use a word opposite number. So the opposite number is the number which added to the given number gives the neutral element 0. So it's kind of minus A. And each element has its, opposite number. And this opposite number in case of multiplication, then it is really always called the inverse element. And this is, 1 divided by A. So, for example, for a equal to 2, its multiplicative inverse is 1/2, because 2 times 1/2 is equal to 1. For a equal to 1/3, the inverse will be 3, because 1/3 times 3 is equal to 1. And all the real numbers, except for 0, do have their inverse element for multiplication. So these are the computational rules, and well, as I told you, later when we analyze the rules for matrix multiplication and matrix addition, we will compare those rules well to this list, and we will look if all the rules are preserved, or maybe there are some differences. There will be differences. Stay tuned. Bye bye.